Hey guys, so today we're going to be talking about trigonometry. This is the first video and the initial steps of when you need to label a triangle and figure out which trigonometric ratio you need to use. So it's so important that you label the triangle correctly first, otherwise your whole answer is going to be incorrect. So the aim of this video, or the learning intention, is to be able to correctly label a triangle and recall the trigonometric ratio for questions relating to a right angle trigonometry. Now, right angle triangles can have four main types of questions when it comes to trigonometry. The first type is an unknown hypotenuse using Pythagoras theorem. And you've already learnt Pythagoras theorem in the previous videos. If you haven't, go watch that video because that's the first step of right angle trig. The second type of question that you can receive is the unknown shorter side using Pythagoras theorem. And that's when you rearrange the c squared equals a squared plus b squared formula and you figure out a side that is not the hypotenuse. The third type of question you can receive is unknown side using trigonometric ratios, which we'll be doing in this video today, and unknown angles using trigonometric ratios, which we'll also be doing the initial stages in this video today. So let's look at what are trigonometric ratios. There are many ways to remember this, but the easiest way is to say Sohcahtoa, and you need to memorize that. There's no other way. You could come up with some funky acronym if you really wanted to, but the easiest way is Sohcahtoa. So memorize that and we'll go through what each one means as we go through the video. Just for a quick preview into what it means. So stands for sin theta, and theta being the unknown angle or known angle, depending on what the question is. Sin theta equals opposite over hypotenuse. The next one for cos theta equals adjacent over hypotenuse. And the last one, tan theta equals opposite over adjacent. Now, all of this may sound like gibberish to you right now, but as we go through step by step, it'll all start making sense. My advice is write Sohcahtoa in the back page where you have all your formulas and important notes. Let's go through some examples. So in this example here, we're going to label the following triangles. Now, the first step of labeling a triangle, if you follow the steps, is the opposite the right angle is always the hypotenuse. So if I look at this first triangle, there's a right angle directly opposite this side. So there's a right angle directly opposite this side is going to be the hypotenuse. So this is going to be hypotenuse. Step 2, opposite the angle is the opposite side. So the angle is there. We know it with the theta symbol, which looks like a Pokemon ball. Opposite this is the opposite side. So this is opposite. And the last side left, we call that adjacent. So let's go through that step again with 1a. So opposite the right angle is always hypotenuse. Opposite the angle or unknown angle, theta, is the opposite side. And the third side that's left on the triangle is called the adjacent. Let's try example B. Following the same steps. Opposite the right angle is always hypotenuse, or H. Opposite the angle is always opposite, or O. And the last one left is adjacent, or A. And as you do more of these, it'll all come very naturally to you. So that was labeling all three sides of a triangle. Let's look at example 2. Now with example 2, it says correctly label the following triangles. But in this case, I only want to label the elements that are noted on the triangle or given. So I have an angle there. That's the angle there. It's 16 degrees. Now opposite the right angle is always hypotenuse. So x is hypotenuse. Opposite the angle is always opposite. So the 15 meters is opposite. Now I don't need to worry about adjacent here because nothing's given there. But that is the adjacent side if you really needed to know. Let's look through example B. Now with example B, we have opposite the right angle is hypotenuse. Opposite the angle is opposite, but there's nothing there. So I'm going to leave it. And the last angle left is adjacent. Sorry, the last side left is adjacent. So here we're using OH and here we're using AH. And all of that will start making sense as we go through. Now to go one step further, the next example says, identify the trigonometric ratio that we use in the following right angle triangles. So the first thing I do is I always write Sohcahtoa so I can figure out which one of these three I'm going to use. So if I use another color, let's start labeling the sides that we know. Opposite the right angle triangle, the right angle is the hypotenuse. Opposite the angle is opposite. I'm using O and H. Now let's look at which one of these three uses O and H. Well, sine uses O and H. That's correct. So it's sine. Let's keep going and checking the rest. Chi uses A and H. We don't have A and H here. Tan uses OA. We don't have OA here. So it is sine that we're using for this triangle. Let's move on to 3B. With 3B, you have hypotenuse. Well, there's nothing there. So I'm going to leave hypotenuse. Then I have opposite the angle is adjacent. So that's going to be A. And the last one, sorry, opposite. And the last one left is adjacent. So I'm using O and A. Which one of these trig ratios uses O and A? OH, AH, OA. There we go. It's tan. So this one is going to use the tangent or tan ratio. Let's move on to C. Now with C, opposite the right angle is hypotenuse. That is given. So I'm going to put a H there. Opposite the angle is O. There's nothing there. So I'm going to leave O. And the third side that is left is A. Now in 3C, I'm using car, AH. Which one uses AH? So if I look through it, so uses OH, not AH. Cos uses AH. Now cos is also called cosine. Now if I use the abbreviations under each of these, this is going to be sin, this is going to be tan, and this is going to be cos. They're just the shorter forms of them. But their real terms are sine, tangent, and cosine. Hopefully you're getting the hang of labeling a triangle and figuring out which one is for what. Let's go on to the last example of identifying the trigonometric ratio for each right angle triangle. So again, step one, we always start with labeling the triangle. But before I do that, I'm going to write Sohcahtoa again. And the more times you write it, the better it's going to sink in your brain. So let's go through the first one and say, okay, if I'm going to label this triangle, I have my right angle there. Opposite is going to be my hypotenuse. I have my angle there. Now the angle looks a bit different, and I'm going to explain that in a second. I have my angle there, and opposite my angle is always going to be opposite. and my adjacent side has nothing on it. So I'm using OH. Sine uses OH. So let's write the whole ratio now. So we know the ratio for Sohcahtoa is that sine theta equals opposite over hypotenuse. And you learnt that right at the beginning, and you should have written that in the back of your book. So sine theta equals opposite over hypotenuse. Now let's go and plug in the values that we know. Sine, and I'm going to use brackets here. Do I know what theta is? Yes. Theta is the angle. And the angle here is 16 degrees and 12 minutes. That's how we read that. 16 degrees and 12 minutes. And we'll go through more of that as the videos go through. So you have sine and then the angle equals, what's the opposite? Well, opposite here is 13. 13 over the hypotenuse, which is x. So now I've written my trigonometric ratio using the values that are given in the question. And later on, you're going to learn how to solve this. But for now, we went from, if you look at example 1, we went from labeling the triangle with all three sides. Then we went to example 2, where we labeled the triangles with only the sides given. Then we went to example 3, where we identified which trigonometric ratio we would use in a question with those elements. And then we went to example 4, where we actually wrote the trigonometric ratio down with the given information or whatever was given in the question. Let's do the last example, 4b. So with 4b, let's label the triangle first. Opposite the right angle is a hypotenuse, but there's nothing there, so I'm going to leave that. Opposite the angle is opposite. So let's use another color so we don't get confused. Opposite. And the last one left is adjacent. Now we're using OA. Which one of the three trigonometric ratios uses OA? That's right, tan does. So let's write the trigonometric ratio down first. Tan theta equals opposite over adjacent. And I've written it in short form there. You can also write tan theta equals O over A, whatever you feel most comfortable with. So let's now plug in the values I know, or substitute in. Tan, what's theta? Well, that's 20 degrees there, that's the angle, equals opposite, which is 15, over adjacent, which is x. It's very important that you plug in the variables exactly in the order they are in the syntax above. If you don't put it in the right order, then you will get the incorrect answer. So hopefully now you have been able to label a triangle, identify which trig ratio applies to that triangle, and then substitute the values in for that given triangle. It's very important you memorize Sohcahtoa and understand how it works, and also understand the steps of labeling the triangle. I would advise you pause the video and write all those notes down in your own words. Now, I have a few questions here for you to try yourself. The first thing you have to do is you have to label these triangles. Then you have to identify which trig ratio to use, and then write the trig ratio by substituting the values in. Pause the video, give it a shot, and then come back for the recommended answers. Okay, you should be done by now. There's the recommended answers. If you got something wrong, go back and check what you did wrong and identify where you went wrong. And if you still don't understand, go watch the video again and pause it and write your own notes in your own words. Hopefully that helped you labeling a triangle and identifying and substituting in the trig ratios. Till next time, take care guys.